the first thing you always want to look at, and it will not always be labeled. And also another call out before I get into that too, is the drawings are something you are going to probably be held accountable for on the EOC style questions. Our quiz, I tried to put enough where you had enough drawings present when you have your quiz, but also without them, because you have to kind of put pencil to paper and draw them. If you try to visualize where all these segments and angles are, even if you're a genius, and I mean this in the kindest way, you're going to pick the wrong angle just because there's so many different little angles that they could be referring to. And then also, most students don't naturally label it A, B, C, D. Most of them do A, B, C, D because we're used to writing left to right is the only reason I've come up with. So again, making sure you label it in order. Wherever you start is fine, but just know that if it says parallelogram A, B, C, D, that it has to be A, B, C, like you're traveling around it. Those are just some huge call outs that I've realized over the last couple semesters that a lot of us want to fight writing it down. If you do it in your head, I'm going to go with an 80% chance we're going to make a big boo-boo. Parallelogram, so usually it's not always like, it's not labeled with your shape, it's in the words or in the instructions, which I know I am the world's worst. So you want to make sure that you maybe highlight or underline, just make sure you know which shape they're talking about. Parallelogram is going to be that's where most of your properties are that apply to all the shapes. But if we're going to find the perimeter, the parallelogram, that means we have 12 and we have 11 around the outside because we're in perimeter. Oh, wow. Sorry, big words. Perimeter is the distance all the way around the shape, and we're just going to add them. So that's the sum of all four sides. And the property you would need to know to be able to do that would be that opposite sides are parallel and congruent. So because this side is parallel to this side, along with this one and this one, that makes them congruent. The single arrow and then the double arrow is the equivalent to when we used to mark them like in triangles in math 2, like that. So you may not see both markings if you happen to run across one that's marked. If they do single arrow, double arrow, that's the same as the dashes. So then I know if this is 10, this also has to be 10, and then this also has to be 12. And so you would just add all four of those together, which would be 44. So your perimeter is going to be 44 units. In this case, it doesn't give you a measure. So 44 units long. If CT is 9, so C to T is 9, what is AT? So that's your unknown for this one. The property you would use there is that diagonals bisect each other. So that means for a parallelogram, that's the only thing that pertains to diagonals. So diagonals bisect. Bisect means cuts into two equal parts. Because this is 9, then I know this is 9 because of the word bisect. So it's going to be 9 again. And then, of course, this would also be the same length of this side. Parallelogram, there's not enough information to be able to assume what that one is because you don't have any other angle measures given in this one at this moment to be able to solve. If it happened to have been a rectangle or a rhombus or a square where they rhombus or square where they do bisect at 90 degrees, you could use Pythagorean theorem along the way. But this is a parallelogram, so it does not pertain. So number 3, and I just try to change colors. You may need to sketch more than one shape if you have multiple questions pertaining to one because it gets very busy. CDA, so CDA, so that's the whole angle, is 60 degrees. And they want us to find CBA, so CBA. This one is our first one. This is my purple X. And then BAD, BAD. This one, we'll call it Y. Actually, we'll do this. We'll call this Z and that Y, since we already have an X on the shape. Now, the rules that would pertain to this, and I'm not getting into too much algebraic, just the basic rule conversation. Opposite angles are congruent. And then, since it's angle conversation with Y, this would be adjacent or supplementary. And adjacent being the angles that are using a same leg or same side as the angle given, or in a row, like when you're naming it. So A and B are going to equal 180. B and C would equal 180 if they're added together. C and D would equal 180 as they get added together, and then D and A as well would add together to give you 180. Supplementary is 180 degrees. You don't use it in this lesson, but again, just a vocabulary. Complementary, it is a fair game for your EOC, is 90 degrees. So complementary and supplementary are the types of angles. I believe that would have been in Math 2 where you were exposed to those. So since this is 60, I know B is 60 because opposite angles are congruent. So CBA is going to be 60 degrees. And then A, so that's 180 minus 60, and I'm not calling it the right letter because A, there's actually 3 angles in this corner, the big one and 2 little ones. So BAD is going to be 120 degrees. And it does matter. So if you say angle A, it's too vague because there are those 3 angles up in that corner. All right. Let's see if I find out. There we go. AT. So A to T in this case is 4x minus 7. And CT is negative x plus 13. Solve for x. Again, we're looking at diagonals. The only really rules, in my mind, I also sort of make a list of rules that deal with diagonals, a list of rules that deal with angles. Not only are my list to the shape specifically, but then I know I can study each one separate and then break them off to shapes as well. Because I've had a lot of students take these distances or these lengths and set them equal to 180, but they're sides. A flat length will never equal 180. 180 is only dealing with your angles, so definitely not sides. This is, again, diagonals bisect each other, so we're going to set them equal, and you're going to solve. Probably already know this, but that's where you're getting your variable on one side and your whole numbers on the other side to solve for x. I like to work towards a positive x, so I'm working towards the left in this case because that's where the bigger x is. So 5x minus 7 equals 13. We're trying to get x by itself, so we're going to add 7. And that gives me 5x equals 20. That's 5 times x, so the inverse operation of multiplication is division. So we're going to divide by 5, and so x will equal 4. Another big call out, if they happen to be kind enough to give you a multiple choice question, some of these don't ask for x. This one did ask for x, but they will ask for the length of AT. So that's another one of those misconceptions I've watched lots of students. You get excited because you got math, you see an answer, you jump on it. Make sure you go back and look for what they're actually asking so you don't answer the wrong question, especially if you did the hard part right. But in this case, it did solve for x, so you're done for parallelogram. But again, just make sure, because they could have easily asked, what is the length of AT? What is the length of TC? Any of that. And no matter which one of the equations you plug in that for, you should get the same answer. Moving right along to rhombus. Rhombus, as I was saying, I think about it as a square because it has the properties of square, properties of rectangles, properties of parallelograms. I'm sorry, not rhombus, backwards. It has the properties of parallelogram in its own set. Square takes the properties of rhombus and rectangle. So like mama rhombus, daddy rectangle, make a baby square is the way that I tried to memorize those as well. But rhombus has some fun properties, and it is one they use a lot in a lot of questions that I've seen so far. So if PS is the square root of 6, what is the perimeter of PQRS? So if this is the square root of 6, that just means that it's 4 times that. You can add them together. We could do 4 times the square root of 6. And that property is just knowing that a rhombus has 4 congruent sides. So 4 times the square root of 6. Or if you did do it, the square root of 6 is 2.44948, blah, blah, blah. Be careful by doing that, though. Where they round matters a lot. But as a decimal, if we used accurate and didn't round to the very end, I can probably give you that guy would be pretty accurate. You may actually see it as a 9.8 as the perimeter when it's 4 times the square root of 6. And what I mean is I would not start your rounding personally here unless it makes note of a certain decimal place and then multiply it by 4. I would try to use the most accurate version. And I put it in a little different just to make sure I was going to be able to discuss each number, because you could obviously put in 4 times the square root of 6 in one line as well, or in Desmos, pretty easy. All right, so number 6, if PQ is 3x plus 7, so P to Q is 3x plus 7, and QR is a negative x plus 17, solve for x. So again, this is using the same rule you use for number 5, so all 4 sides are congruent. And congruent meaning they are the same. So we're going to take the 2 and set them equal to each other. So 3x plus 7 equals negative x plus 17. We're going to solve. We want to get the x's on one side, whole numbers on the other side. Again, I'm going to work towards a positive x. I'm going to take that negative x and move it over here, making positive. So that's 4x plus 7 equals 17. We're trying to get 4x by itself. So we're going to subtract 7 to make it go away on this side. And that's going to give me 4x equals, making sure I'm looking at all the right things. Yep, equals 10. Divide by 4. 4x equals 10 over 4 is never going to be how you see this answer, because we are in Math 3, and they're either going to use a decimal, or if they leave it in fraction form, it is definitely going to be in its most reduced form. So that's going to be 5 over 2 at best, or worse if you don't like fractions. But you always want to reduce your fractions. There is in Desmos a way to reduce your fractions. I feel like it is easier on your TI-84 to reduce your fraction, because you would just type in, so on a TI-84, you're going to do 10 divided by, is it 5, 2, 4, divided by 4, get a decimal. If you hit the math button, which is right underneath alpha, math, and then you see frac, you hit enter, and you get 5 over 2. So it reduces it for you in the event you cannot reduce. Now, in Desmos, which is embedded in your EOC, every time, make sure that that day you know where that is. If you type in, whoops, what was having a fit? 10 divided by 4, enter, you get 2.5 as a decimal. Over here, there's a round circle with the 2 little squares in it. If you click it, I'm sorry, my computer's lagging, it gives you the reduced. So this is where you reduce the fraction. If you want the decimal back, you just click it again, and it should go away. Yeah, my computer's not being very happy right now, sorry. So when it's not dark, you have your decimal, darken it, and it will reduce your fraction. If it gives you the same fraction back, it is in its simplest form. So that's a way to make Desmos do that for you. So just type in your fraction, look to the left, and that guy should reduce it for you. All right, so number 7, if PSM, so PSM, so we're looking at this corner right here, is 22 degrees, and find RSM, so this is going to be our first X, and then SPQ, so SPQ, so we'll call this whole one our Y. Diagonals of a rhombus. What do you know about diagonals of a rhombus other than they bisect each other because it is a parallelogram? They also bisect at 90 degrees. So these guys are 90 degrees, which is not pertinent to this question, but just another one of your rules about diagonals as far as angles are concerned. And then they bisect opposite angles. So bisect opposite angles. And opposite being like Q and S, and then P and R. So because this is 22, X is also going to be 22, which means the whole angle is going to be 44. And if I know this is 44, we're going to go back and pull that rule from parallelograms that consecutive angles or adjacent angles are supplementary. And I think they actually use consecutive now. It just came out of my mouth right. That sounds better. So supplementary, and supplementary again is equal to 180. So their sum equals 180. So you can take 180 and subtract 144 from it. And that should give me 136. So SPQ, that big angle at the top, is going to be 136. Now, number 8, PMQ is 4x minus 5. And that's this guy right here. Solve for x. This is where you would have to remember that the diagonals of a rhombus bisect each other at 90 degrees. So intersect or bisect each other, because they do bisect, because this guy will always be congruent to this guy, and this guy will be congruent to this guy. But the actual full diagonals are not congruent. And if you think about visually, when it got kicked over, then it would take longer to walk from S to Q than P to R, because they are closer together in distance, just even visually. But that 90 degrees, so 4x minus 5 equals 90. We're going to solve for 4x, solve for x. So we're going to add 5 to both sides. 4x equals 95. Then we're going to divide by 4, because that's the inverse operation of that 4 times x. So 95 divided by 4 is 23.75. So it is a wild little decimal. That's fine. You could do 95 divided by 4, but it does not reduce. So probably not the way they will leave it. But again, as I've mentioned before, like talking about square root answers or in terms of pi answers as far as your EOC, read the direction and give the answers that it is that the directions ask for. And if you have multiple choice and they aren't in the form that you are used to, then go back and manipulate them. Make them the form you need them to be. All right, last but not least, we have a rectangle. Whoop. It says use the quadrilateral. Okay, so it's just a quadrilateral. Oh, now we're going to prove other things. Got it. It's just a quadrilateral. If WX is congruent to YZ and WZ is equal to XY, would this be a rectangle? Is that enough information to prove this a rectangle? The answer would be no, because those markings alone are only going to state that it's a parallelogram. You would need more information. You would need the fact that there's 90-degree angles. You would need to know something about diagonals. The 90-degree angles would be your telltale, though. And then I think that's the only one that would really help you decide this was a rectangle. Maybe if they told you diagonals were congruent as well, because in a parallelogram they're not congruent. They're only congruent in a square and a rectangle. I think that's the only other one that could help. But the 90 degrees is the most important. So if WZY, so WZY is 90 degrees, must it be a rectangle? With all that added information, so if that's the only statement you have, it's not enough. If it's tacked on with number 9, it is enough. If it's the only statement, it could be a rectangle or a square, which a square is a rectangle as well. It has all the properties of a rectangle. So actually I take that back, and this is going to be a hard yes. You may, if it says, could it be a square? That's not enough. Then you need to know that all 4 sides are congruent. So yes, as far as a rectangle, knowing that that is 90, because we know that opposite angles, this would be 90 as well. Consecutive angles are supplementary. So in turn, it would tell you that all the rest of the angles were 90 as well. And for those to be 90, this has to be perpendicular. And this one also has to be perpendicular, which rolls into the transversal and parallel line conversation that I was talking about from Math 2, which you don't have to remember, but that's your reason why. So if the information in problems 9 through 10 are both true, must it be a rectangle? And that would be yes. And I guess depending on who wrote this worksheet, again, they could have said number 10 could be a no and that it could be a square. But if you really start getting into the games, a square is a rectangle, but a rectangle is not a square. Again, like I said. So a little gray on number 10 as to whoever made this worksheet. But definitely 9 and 10 together are going to give you a rectangle because it doesn't state that all four sides are congruent, which would be necessary for it to be called a square. And it's more information than just to be called a parallelogram. But it is a parallelogram, or it is a quadrilateral. Hopefully also you've already realized that you can call it a quadrilateral, you can call it a parallelogram with 9 and 10, then you can call it a rectangle. And the parallel to that, what I would say is you're a student in Miss Sigmund's class. I'm sorry, let's say you're a student, and like in this case, you're a female student, and then your name is Sigmund. So all three of those things are true. It's just getting down to the details, the most specific name. Like if someone walked into the classroom and said, hey, female student, you may or may not know it was you because the whole room is students. And there might be other females in the classroom. But if they come into the room and they call you by your name, then it's speaking to you. So rectangle would be this shape's specific name, whereas quadrilateral would be getting a little more specific in that it's a four-sided figure. And then, I'm sorry, the most vague would be quadrilateral. Parallelogram's getting a little more specific because you know that opposite sides are parallel, but it is all of those things. So there may be a question along the way like, what is this not? And you're thinking about all the different names that would be accurate for this shape, which would be where your shape tree, like family tree of shapes, could be helpful. If WY is 15, so WY, the whole thing is 15, and WZ is 9, WZ is 9, what is YZ and what is XZ? So I'm going to draw this one as a dash. We'll look at it in a minute. So knowing this is a right triangle, I have a hypotenuse and I have one of the legs. So this is where we're going to do a squared plus b squared equals c squared. So a squared and b squared have to be the legs, and c squared is always the hypotenuse. So 9 squared plus we can put x squared equals 15 squared. And whichever one you put in the AB spot does not matter. The only one that does matter is it has to be hypotenuse in the C spot. And so that's going to be 225. And that's going to be 81. And then you're just going to solve for x. So I'm going to subtract 81 from both sides. And I get x squared equals 144. Now, how do I undo squaring something? We got to make sure, remember that it is not divide by 2. We want to take the square root. And remember, algebraically, every time you take the square root of any number, there's a positive and a negative. But in this case, the only one that's going to make sense since we're doing length is our positive 12. So x is going to be 12. And then you're going to work it to find this guy. I'm lying. You don't have to work it. Diagonals are congruent in a rectangle. So since this one was 15, this one was 15, this will also be 15. And if that rule escapes you, but you do know a rectangle has opposite sides congruent, then I have a 9 and a 12. And then you could do Pythagorean theorem using this triangle, but solve for the hypotenuse, and it will work out to where it's 15 because it is a repeat of the other triangle. The givens are just different for that case.